The concept of recursion will always be complicated if you don't know how it operates and why do we need them so badly. In this video, we have covered recursive functions in JavaScript in depth with the help of real-world examples. And most importantly, this video illustrates the evolution of call stack while executing the recursive function using self-explanatory diagrams. Let's start with the definition itself. Recursion is the act of function calling itself. Recursion is used to solve problems that contain smaller sub-problems. I know this definition itself is a confusion. And if you have gone through other materials on recursion before, you might be feeling like an endless function execution chain. Don't worry, we are going to put an end to this endless play. Now, staring at the definition won't be helpful enough. Instead, let's go for a thorough inspection with few sample programs. Now, suppose we want to write a JavaScript program to reverse a string and assume that we are not allowed to use any impl functions. How will you do it normally without recursion? Most of you might have thought about doing it using for loop or any other loop like this. So here we have the function reverse string. Here I have used this prefix underscore just to indicate this is the normal way of solving this problem. In a bit I will be writing a function using recursion without this underscore. Okay, now let's call this function with this string morning. This function returns the reverse string like this. So I have to put this function call in a log statement like this. See, here we have the reverse string. Now for this function we have this parameter input, and here we have a local variable to store the reverse string, and here we have a for loop just to iterate through characters inside this pass string here. So it starts from this character G, it is saved to this local variable here. In next iteration the second last character N will be appended to the result. Like that, this for loop will concat the characters inside this string in reverse order. And that's how a string is reversed inside this function. Now let me show you how to write a recursive function for the same problem. First of all, how could we say there is a recursive way of solving this problem? It's already mentioned here. Recursion is used to solve problems that contain smaller sub-problems. Now I have an idea to split this solution into smaller sub-problems. So let's try to solve this function using recursion. So here we have the function reverse string. We have a single parameter input, and here we have the function body. I'm going to split this function like this. Okay, get first character. I want to make this first character as the last character, and that's how we reverse a string, right? First character as the last character, and then rest part of the string should be called for another reverse operation. So reverse rest of the part. Okay, this is how I'm going to split the function into smaller sub-problems. So first of all, we have the return keyword. Now first of all, let's retrieve the first character from the string. For that, we can call this string function char at. So this will retrieve the character at the index 0, which means the first character from the string. Now we have to find the reverse of the same string excluding the first character. And we have to append that just before the first character. So for finding reverse of a string, we'll be calling the same function, and that's why we are calling this function as a recursive function. Now inside this function, we have to pass the string excluding the first character. For that, we have a function called substring. So input dot substring. Now what this function does is, it will take the substring from the index 1, which is here, starting from this O to the end. So the entire string, excluding the first character, is passed to this function here. Substring. We have discussed these functions char at and substring in our separate JavaScript string tutorial along with other string functions. Now this is how we split the solution into multiple sub-problems. Now assume we are calling this recursive function with the same input morning. During the first invocation, the first character M will be here, and rest of the string which is starting from here to here should be passed to the next call here. And in that function call, the first character O will be taken out, and rest of the part will be passed again to the same function reverse string. And this will go on until there is nothing to pass to this function reverse string, and it will happen once the invocation reach up to this last character here. In that case, this parameter will be having an empty string. To handle this case, we will be having an if clause like this. If input is equal to an empty string, we just need to return an empty string like this. Now a condition or a clause like this is necessary to stop the further execution of this recursive function. If there is no such a condition here, this function will be indefinitely called without an end. So in any recursive function, we need such an end condition like this. Okay, now let's try to reverse this string using recursion. So I will just remove this underscore, and here we have the recursive function called. Sorry, we have a typo here. Boom, that's it. This string is reversed using this recursive function here. Now you can try this function with your name, or you can try with a palindrome like race car. A palindrome is a word which is same even after reversing it, like race car or mom or dad, etc. Let's try the same example morning, and let's check what is happening behind the scene. I will be explaining how this function is getting executed using the step-by-step approach, and finally I will be explaining the same with the execution stack and stack frame. So first of all, we have called this function reverse string. Okay, reverse string, and in short I will type it as reverse. Into this function we have passed morning, and during the execution this return statement is calling the same function with a different input. So I will represent that like this, reverse, and here we are calling the same function without the first character m, and the same character is concatenated at the end. Okay, now let me duplicate this line. Now during this function execution also we have this return statement, right? There also the same function is invoked by removing the first character, and it is appended at the end here. And this process of calling the same function reverse will go on until we only have an empty string to pass to this function reverse. See, finally we have a situation where we only have an empty string to pass to this function reverse. Now what happens when we pass an empty string to this function? This condition here, this if clause will be executed, and thereby it will return an empty string, right? Let me duplicate this instead of this function. Now we can replace this function invocation with an empty string. That's it. We don't have any function to invoke because of the limiting condition here. Otherwise, the function will be invoked indefinitely. So this limiting condition or if clause here isn't necessary, is a must in recursive functions. Now finally, the concatenation in this order will result in our final output here. Now I hope you got a brief idea on what is happening behind the scene when you execute a recursive function. We have thoroughly explained call stack and execution context in previous session. If you haven't watched that already, I highly suggest watching the video later. I have given the link in video description and inside the iCard top right corner. Now it will become more interesting if we explain it using execution stack and stack frame. So here it is. During the first invocation of the function, there will be a stack frame like this. It will end up in calling the same function with the same input by excluding the first character, and the same excluded first character is appended at the last. So this is the first stack frame added to the execution stack. Now to execute this function, a new stack frame is pushed. There also the same function is invoked with a substring excluding the first character, and it is appended at the end. So each time we call the same function, the same operation happens. Okay, and finally we will reach in a situation where we only have an empty string to pass to the function reverse. In that case, this limiting condition or if condition will be reached, and for that function invocation an empty string will be returned, and finally there is no function to invoke, and that will put an end to calling another function. So here we have the last stack frame. It is having the value empty string. Now after returning the empty string, this stack frame will be removed, and this function is returning the value empty string, and that empty string is concatenated with this g, and it will end up in this string g here. Once we are done with that concatenation, we can remove this stack frame also. So this stack frame will be deleted in a moment. Here we have the concatenation result g, and which is the value of this function call here. okay, and that G will be concatenated with this N and it will end up in this value Gn. And this process of concatenation and removing the topmost stack frame will continue until there is nothing left in this execution stack. And finally, we will get the reverse string. So this is what happening when you call a recursive function. It will end up adding more and more stack frames when you call a recursive function, because we are calling the same function again and again until it reach up to a limiting condition. All of the function execution in between will be added to the execution stack in the form of stack frame or execution context. Now let's check few more common problems where we can use recursion. Now let me show you a simple program counting down from a number up to 1, which is a common example to demonstrate recursive functions in JavaScript. So here we have the typical way of solving this problem using for loop, counting down from n. So here we have the for loop to print the numbers starting from this given n up to 1. Iteration variable starts with the given number, and on each iteration it will be decremented by 1 up to the value 1. Now let's try calling this function with a number 10. So here we have the output. It is starting from 10 and it is counting down up to 1. Now let's try to solve this problem using recursion. First of all, we'll be printing the given number into the console. After that, we have to print the next number just below this number. For that, we will call the same function and we are passing the number just below this given number n. So we are calling this function inside itself. So there should be a limiting condition to block the indefinite function invocation. So here we go. If n is less than or equal to 0, we need to stop the execution of the function, so we just need to pass return here. Now let's check whether it works or not. So instead of this normal way, let's try this recursive function. Boom, it works. Now I hope you understood recursion better from this simple example here. Now some of you might have this question. In previous example of reversing a string, from the limiting condition or if clause, we have been returning an empty string. But here inside this if clause we only have a return keyword. Why is that so? It entirely depends on the logic of the problem. In previous example, we have been creating a sequence of concatenation of characters in reverse order. And the final result or the reverse string can only be produced after concatenating all the characters in reversed order. So in previous example, instead of returning an empty string, if we were using just a return keyword like this, the final call of the function will end up returning an undefined. If we were trying to concat undefined with other characters, it will end up in undefined. So in order to avoid that, in the final limiting condition, we are returning an empty string. In case of this problem here, each of the function execution here is independent of the previous function execution, meaning each of the function execution here is printing a different line inside this console window here. So when n is equal to 1, this line will be executed and thereby this line is printed here, and next function call is called with the value 0. And this limiting condition will be reached, so we just need this return statement to stop the further execution of the function. So I hope you understood how we treated this limiting condition in both of these examples differently. Now there are other problems commonly used for demonstrating recursive functions, like factorial of a number, Fibonacci series. Both are related to mathematical concept, then finding sum of digits in a number, etc. These problems can be split into smaller sub-problems as we have done so far. So it's definitely possible to find the solution recursively. Try solving any of these problems and let me know how it goes in comment section below. While explaining the previous example, in our first example we have explained the evolution of call stack during an execution of recursive function. Even though the function is defined with minimum number of calls, while executing the program, more and more execution context or stack frame is pushed to the call stack based on how lengthy is the input. Suppose in case of this problem here, if we pass 100 here, it's gonna take 100 stack frames. Now let's try 1000. It's gonna take 1000 stack frames to be pushed to the call stack. Now if I pass 1 million here, it's gonna push 1 million stack frames, and finally it will end up in stack overflow because the memory allocated for the call stack is limited. See, here we have the error maximum call stack size exceeded. It's because of the repeated function call causing pushing more and more stack frames or execution context to the call stack. If it exceeds the memory allocated for the call stack, we will get the error. And it's possible for most of the mathematical problems like these involving number. Because in real life, there will be a situation where we need to pass a higher number. In that case, recursive function is not feasible. But in case of problems involving tree-like structures, graphs, etc., recursion is the best choice. For example, consider this problem here. You have given the folder structure and you have to find the empty folders within it. And first of all, we have this my computer, and inside that we have 3 folders representing local disk C, D and E. And inside this local disk C we have an empty folder pictures, and inside this folder downloads we have the installation file for Chrome web browser. This local disk is empty, and this local disk E is having a folder softwares. Inside that we have the MS Office installation file. Now this folder structure can be represented with this object here. Each of the folders here is represented with an object containing 2 properties, the title representing the name of the folder, and this property children contains the subfolders inside them. So for empty folders like these pictures and this local disk D, the children's array will be an empty array like this. And these files also, these exe files also is represented with the same object, but in case of those such files, the children's property will be null, representing they are a file, not folders. So inside them we don't have any subfolders. Okay. Now we have to find the empty folders and to the path to the folders when we have given a folder structure like this. For problems like this, recursion is the best choice. So first of all, let me get rid of the previous program here. Now I will be saving this object representing the folder structure in a separate variable like this. Let folder structure is equal to this. Now let me collapse this object so that we can see the rest of the actual function, recursive function. So the object is saved inside this variable folder structure. Okay. Now let's try the function, recursive function, to find the empty folders within this folder structure. Find empty folders. For this function we have 2 parameters, object and path, and the default value of this parameter is an empty string. In order to check whether a folder is empty or not, we have to go through each corresponding folder's object, and we have to check the children's property or array whether it is an empty array or not. If it is an empty array, we can say the corresponding folder is an empty folder, and we have to find the corresponding folder path also. So this object here is representing the outermost folder, which is this my computer. So first of all, we will check its children property, and this children is of the type an array. So we have to check each of the object or each of the folders within it. So we'll be using a for loop here. So index I, and the number of iterations will be as much as elements inside the children's array. So we can do this object dot children dot length. If you are already aware of array functions for each, you can use that function to loop through this array here. In this series of JavaScript tutorials, we haven't yet discussed the array functions. We'll be discussing that from next session onwards. So I will be using for loop for this problem here. So here we are going to iterate through the subfolders or children of this object or the parent object passed to this function here. And inside this loop, we'll be calling the same function find empty folders, and here we'll be passing the children object itself. As I said, inside this children array, we'll be having object representing the subfolders here. The children array of this my computer is having these subfolders here. In order to check whether these subfolders are empty, we'll be calling the same function with the object corresponding to these folders here. So we can do this object.children, and we'll be using the array index here. Now we have to pass the value for this parameter path, because that's the only way to remember the path that we have traversed while finding the empty folder. So initially by default path parameter is empty, and upon each recursive call inside the function we will be passing the name of the file that we have covered. So object dot title, which is the name of the folder that we have checked, and finally we will be appending the / here. So initially this parameter path will be an empty string, and then as we go down in this folder structure, each of the covered folder name will be appended into this string. So we will execute this for loop here if current folder is not empty. Now let's check whether there is an empty subfolder. Since we are implementing this function recursively, we must provide a limiting condition also. So first of all, we could say if the children property is null, meaning the current object is representing a file like this installation Chrome exe file, or for this file MS Office. So for those files, the corresponding object children property will be null. In case of empty photos, it will be an empty array. So we'll be mentioning those two cases in our if clause here. If object.children is equal to null, meaning it's a file. So there is no further inspection needed for a file. So we will just return here. Else if the children array is an empty array, we could say this is an empty folder. Okay, so we can handle that situation here. If children, the length will be 0, right? Now here we can print the whole path to the empty folder. Path, so this path parameter will be having the path up to the parent folder, and we just need to append the current folder name. So we could do this object dot title. That's it. So this means an empty folder. Okay, now let's call this function with this given folder structure here. Boom, that's it. These two folders are the only empty folders inside this given folder structure. So recursion is the elegant solution for problems involving tree traversing or graphs. Now that's all about recursive functions in JavaScript. In next few videos, we'll be discussing array functions in JavaScript. If you found this video helpful, please consider subscribing to this channel. It will definitely motivate me to make more helpful videos like this in future. Please like and share this video with your friends and colleagues. See you in next video.